So we will see another problem which is from the textbook, which is example 4.14, which is related to the energy density in the electrostatic system. So there are three charges. You can see three charges, the point charges. Okay, three charges, point charges, like means one is -1 nanocoulomb, and another charge is 4 nanocoulomb, and another charge is given as 3 nanocoulomb. Okay, these are the three charges. The first charge is located at 0, 0, 0. So I will write it here. This is 0, 0, 0. And another charge is located at 0, 0, 1. And another one is at 1, 0, 0. So these are the location of these three charges. Now what we want to find, what is the energy density in the electrostatic system? What is the total energy density in the electrostatic system? Now the total energy is given as half of, okay, in this case there are three charges. It is half of Q1 into V1 plus Q2 into V2 plus Q3 into V3. So first of all, we want to find what is V1, what is V2, what is V3. So what is V1, V2 and V3? So whenever we are talking about V1, it is due to the effect of 2 and 3. When we talk about the effect of, when we talk about V2, V2 is due to the potential, due to V2 is the potential at the point 2 due to the charges 1 and 3. So this is the potential V1, and here the potential is V2, and here the potential is V3. So whenever we talk about V3, V3 is the potential at the point 3 due to the charges 2 and 3. Okay, so let's say this is the charge 1, or let's say this is Q1 and this is Q2 and this is Q3. So you have Q1, Q2 and Q3. So when we calculate V1, please note that V1 is the potential at point 1 due to the charges Q2 and Q3. Now we will find V1. For finding V1, you know that the formula is, the general formula I will write, to find the voltage, V, we have the general, due to some charge at a point R, which is given as Q by 4 pi epsilon 0 into R. So R is the distance, okay, from the charge Q. So in our case we can calculate V1 as, V1 I told you it is due to Q2 and Q3. So Q2 divided by 4 pi epsilon 0 into the distance. What is the distance? So that's very, very important. So this is the distance. So the distance is like 0, 0, 0. So it is the distance, this is the distance from V2 to V1. Okay, so the distance from V2 to V1 is given as 1, okay, 0, 0, 0 minus, so this is the vector is given as 0, 0, 0 minus 1, 0, 0. Okay, or you can say it is minus AX, or the magnitude of this, the magnitude will be equal to 1. Okay, the magnitude is equal to 1. So the magnitude is equal to 1. Okay, magnitude is equal to 1. Now plus Q3 divided by 4 pi epsilon 0, and what is the magnitude? What is the distance from V3 to V1? So we have to find this. This is nothing but, again you see 0, 0, 0 minus 0, 0, 1, and what is the magnitude of this? Again the magnitude is 1. So we will get the magnitude as 1. Okay. Similarly, we can find for V2 also, but V2 is due to other charges. This is nothing but Q1 and Q3. So this become Q1 divided by 4 pi epsilon 0. Between 1 and 2, what is the distance? So between 1 and the charge 2, the distance is again, I think the distance is again 1. Okay, 1 unit. So it is 1 unit, then it's 2 and 1. Okay, plus then it's due to Q3 divided by 4 pi epsilon 0 into distance between 2 and 3. That's what we didn't find it. So the distance between 2 and 3 become, it's like this. Okay, the distance between 2 and 3, or we can say like this, it is a 2 and 3. So this become 1, 0, 0 minus 0, 0, 1. So you will get 1 minus 0 and again 0 minus 1. So the magnitude will be equal to square root of 1 square plus 1 square, that become 2, square root of 2. So this become square root of 2. Okay, square root of 2. And next you will get the other part as V3. So V3 is due to the Q1 and Q2. So this is Q1 divided by 4 pi epsilon 0. And what is the distance between 1 and 3? So we will be finding what is the distance between 1 and 3. The distance between 1 and 3 is already, we have already found it. It is again 1. Okay. Then plus Q3 divided by 4 pi epsilon 0 into the distance between, not Q3, it's Q2, distance between 2 and 3. What is the distance between 2 and 3? The distance between 2 and 3, we have already found it. It is square root of 2. Square root of 2. Okay. So we will use these expressions in the equation that we have shown here for the total energy in the electrostatic system. So W is equal to half of Q1 V1 plus Q2 V2 plus Q3 V3. So this become half of Q1 into what is our V1? V1 is Q2, V1 is this equation, Q2 by 4 pi epsilon 0 into 1. Okay, then Q3 divided by 4 pi epsilon 0 into 1 again. Okay, again 1. I think it's correct. Let me check it. Yeah, it's fine. Then plus the other one is like Q2 multiplied with V2. What is V2? V2 is Q1 by 4 pi epsilon 0 into 1 plus what is Q3? Q3, then it is Q3 divided by 4 pi epsilon 0 into root 2. Okay, then this plus the last one is Q3 V3, Q3 into what is V3? V3 is equal to 4 pi epsilon 0, Q1 by 4 pi epsilon 0, Q1 by 4 pi epsilon 0 into 1 plus Q2 by 4 pi epsilon 0 into root 2. Okay, so we got it, and we know that we know that it is given that Q1, Q2, Q3, everything is given, and you know Q1 is -1, Q2 is 4, so -1 nanocoulomb, 4 nanocoulomb, and the last one is 3 nanocoulomb. Okay, 3 nanocoulomb. So everything is given, so you can substitute all of them in the equations. Okay, so you can make use of them, all these things you can make use of them in the equation. And also epsilon 0 is 10 power minus 9 divided by 36 pi. You can also substitute this, and finally you will get the answer. Okay, I will not write everything, so I will be writing the final answer as 13.37 nanojoules. Okay, so you have to substitute this nano with 10 power minus 9. Okay, nano means 10 power minus 9. So if you calculate, you will get 13.37 nanojoules. So I hope it is clear to you. You can see this problem in the textbook Sadiku, and it is example 4.14. Okay, thank you.